Greetings. Melodic Intelligence, an investigation for Indian classical music generation. With a growing interest in AI music composition, this project aims to fill a gap in the research on AI music generation for Indian traditional music by exploring its potential. The focus of this project is on generating tracks for a wide range of instruments using cutting-edge techniques such as recurrent neural networks in machine learning. By leveraging these technologies, we hope to create unique and novel music pieces that capture the essence of Indian traditional music and pave the way for future innovations in the field. The audience and stakeholders include music composers, music producers, music lovers, music researchers, and music therapists. A raga is a musical scale with specific melodic rhythmic patterns. Each raga has its own unique mood, personality, and emotional expression. Thousands of ragas give a wide selection of music to compose for different purposes. It helps in creativity, efficiency, diversity, accessibility, and personalization. The mood of a raga is selected by specific melodic patterns that are unique to each raga. Each raga evokes a particular kind of emotion. For example, Hindol raga produces joy, playfulness, and improves attention. Similarly, other ragas can produce various kinds of emotions such as romance, sadness, compassion, peace, devotion, and so on. Music track structure consists of various elements such as instruments, rhythm, chords, melody, etc. In music composition, machine learning models can assist in generating each element of a song. This can help expand the horizon of music composition. Machine learning application involves recognizing the instruments and generating new instrumentals based on the existing music. When it comes to percussion, various rhythms and beats based on the existing patterns can be produced by the machine learning model. Performing different permutations and combinations, different kinds of melody can be produced to assist in generation of new tunes. It could even generate new harmonic progressions and chord sequences suitable for the track. When all these elements and more are played together, it forms a musical track that can be independently played or used as a karaoke. It could even be used to produce background music for movies or video games. So, is it a replacement for a music composer? In certain cases, it can produce independent tracks, but most often, it helps the music composer to expand his creativity. The dataset used in this project is the Raga recognition dataset that contains the two major parts of Indian classical music, such as Carnatic music and Hindustani music. As the project evolves, various other datasets will be researched to add to the variety and depth of the tracks. This dataset will be fed into a LSTM network that is developed using TensorFlow. The machine learning model architecture follows the sequence of data preparation, neural network model creation to produce the next best node through proper training. LSTM or long short-term memory architecture is selected in this case as it is perfect for capturing long-term temporal dependencies in music because of the repetitive structures and patterns in time and dependencies. We convert the input into a time series for the machine learning model to process data. LSTMs are good to recreate the structures and patterns as they have the memory to handle long chunks of melodies. Depending on the memory, RNN LSTM will produce one note at a time, and it will feed the output into itself to produce another note, and so on. Finally, we have a series of notes generated to create a track sequence. To improve the accuracy, various hyperparameters such as the number of LSTM layers, hidden units, the dropout rates, the learning rate, the batch size, the sequence length, the number of epochs, and so on will be experimented to produce the best accuracy possible. As the Indian classical music is highly complex and contains different blends, slides, and variations, it becomes the biggest challenge in this project. Another challenge would be playing with different kinds of machine learning models such as LSTM, GRU, GPT, autoencoders, and so on to select a model or a combination of models that produces the music within these constraints. In short, this project involves collecting the right data set, experimenting with different machine learning models to produce new sequences of chords and notes that could lead to a breakthrough in music composition. Research has shown that ragas have therapeutical effects to enhance in the healing of various diseases such as headache, asthma, heart ailments, high blood pressure, sleep disorders, anorexia, indigestion, arthritis, hypertension, anxiety, and so on. In the future, an application could be developed based on this model to allow the user to self-compose a track based on these particular purposes at the comfort of their home at any time. The future of AI-based music generation is full of exciting possibilities, and let's look forward to explore these in the upcoming research. Thank you.